Good morning, my dear students. Today, the topic of my lecture is light emitting diode. Light emitting diode, as its name suggests, it is the diode which emits light. Diode is used for the transference of current, for the passage of current, and with the passage of this current, electric current, we produce a form of heat and light. And that is known as your light emitting diode. That is termed as your light emitting diode. So this is a major functionality of this light emitting diode, why it is being used. Okay, so let's start with the introduction of light emitting diode. What do you mean by light emitting diode and why it is being used? An LED screen is actually an LCD screen. What do you mean by LED screen? LED screen is a light emitting diode screen, is actually an liquid crystal display screen. We all know that LEDs are being used in almost all electronic gadgets nowadays. If you see the displays that is shown on the mostly on the shops, on the above top of the shops, there's a display of the name of the shop and that ongoing process of LEDs patterns they are drawn, lights, the blinking colorful lights are there, small LEDs are being used over there in a pattern to form a displays. So that is a major LED application. Then we have the LED TVs nowadays, which have a very good resolution and light performance. Then LCD screens are also there, where we use a liquid crystals. In case of LEDs, we use a light emitting diodes, and in case of a LCD, we use a liquid crystals for display of light. But instead of having a normal CCFL backlight, it uses a light emitting diode as a source of light behind the screen. In this case, we are not using any CFL lights. There are normal fluorescent lights we are using at our homes for the illumination purpose. Like we have the lamps, we have the tube lights. So these kind of lights are not used nowadays for having this kind of displays. They are using small diodes in the form of light emitting diodes are being used to form a kind of a display. And LED energy is more efficient. It's a very efficient kind of system. Why it is efficient? Why it is efficient? Because it is efficient because we in this case we are using the what? We are using the LEDs in the forward bias junction. We're not using the reverse bias junction. We're using the forward bias junctions. And when we use the things in a forward bias function, there is a huge amount of recombinations are possible of electron hole pairs, and these recombinations further produce what? They further produce a huge amount of energy. And energy in case of a light emitting diodes is emitted in the form of what? It is emitted in the form of heat and light. So the energy in the form of heat and light is emitted in case of a light emitting diodes. So light emitting diodes are essentially the PN junction diodes or the opto semiconductor devices. They are known as the optoelectronic devices also. Why they are known as optoelectronic devices? They are known as optoelectronic semiconductor devices because they produce the energy in the form of light. And when we talk about optics or opto, that means we are talking about light. Optics means light. So they are taking the electrical current, they are producing electrical current, but the output, which is in the form of energy, or the output energy, is always in the form of what? It is in the form of light and heat. So light emitting diodes or the LEDs are essentially the PN junction diodes. The normal working of it is as usual as your PN junction diode. As a PN junction diode works, it works in a similar manner. But the only difference over here is that in case of your light emitting diodes, we are using the output or the energy in the form of heat and light. So they are also termed as what? They are termed as the optoelectronic devices. But normally when we talk about your PN junction diodes, the output is in the form of what? It is in the form of electric current. But here the electric current that is produced by the recombination of electron and hole pairs, they are producing the energy or output in the form of light and heat. Because whenever the current is agitation of the charged particles is there, and the production of current is there. Production of heat is a byproduct of the production of current, because whenever there is a current, there is a production of agitation of particles, there is a byproduction of heat over there. So that heat is given by this light emitting diode, or is liberated by light emitting diodes. It emits a monochromatic single color light when operated in a forward bias direction. So it is always a monochromatic or a single color is being produced when operated in the forward. It works only in the forward bias direction. It doesn't work in the reverse bias direction. Reverse bias will damage your LEDs. It will not be able to produce any functionality. It won't be able to operate in the reverse bias condition. It can operate only in the forward bias condition, and it produces single color of light when operated in the forward bias direction. So LEDs are basically doing what? LEDs are basically converting the electrical energy into the light energy. They're basically converting the electrical energy into the light energy. So there are three main points over here. They're basically converting the light, this electrical energy into light energy. That is, it works on the principle of electroluminance. Electroluminance means with the help of electrical supply, the luminance or the light is produced. Secondly, it is an optoelectronic device. Optoelectronic device means production of light with the help of your production of current. Then it is working on the forward biased voltage. It doesn't work in the reverse bias voltage. Now LEDs are what? LED is a semiconductor chip and a PN region. LED is a semiconductor chip on the PN region. That is P and N. P and N means, the P means the positive region, the P-type region, which is comprising of what? The P region is comprising of what? The P region is comprising of the holes as a majority carriers, which are the acceptor ions. And N region is comprising of what? The N region is comprising of electrons. Electrons means where there is a majority of electrons and minority of holes. There is a minority of holes and majority of electrons. And in case of your P region, we have the majority of um, holes and minority of electrons. So that is what is actually is happening in case of your P and N regions of your LED. This is what is actually happening, and this is your the LED devices which are used, LED diodes which are used over here, and this is what is actually happening over here. Okay. Now, how this LED is working? How does it work? When sufficient voltage is applied to the chip across the leads of LED, when a huge amount of, or the amount of voltage that is required for the normal functioning of this LED, when that voltage is applied to it, when applied to what? Applied to your light emitting diode, then what is happening is electrons can move easily in only one direction across a junction between the P and N regions. When the voltage is applied and the current start to flow, electrons in the N region have sufficient energy to move across the junction into the P region. Now, when what happens is operation of this PN junction or this normal LED diode is actually working in such a way that when we apply amount of voltage that is required to transverse the particles from one region to other region, when we are transversing those particles from one region to another region, suppose in case of your PN diode, we are having N region and P region, and P region is comprising of what? It is comprising of holes as the majority carriers, and only the holes are there in case of your P region as majority, and electrons are there, but they are in minority. They are in minority particles. They are the minority carriers in case of your N regions. On case of a P region may majority carriers are your these holes, and minority carriers are your what? They are your what? They are your electrons. Okay, so that is what is actually happening in this case, and we are going through this voltage. So with the help of forward bias, the majority carriers, they move from the N region towards the P region. They move from the N region towards the P region, and they form the recombination process, and they help in the production of energy. And energy is always in the form of what? It is a form of heat and light. So when the voltage applied to your LED circuit, what is happening is, when we provide the forward bias voltage, the sufficient electrons, because electrons have high mobility as compared to holes. So electrons, they start moving from the N region towards the P region with a huge amount of energy, with sufficient amount of energy. So that is what is actually happening in case of your LEDs. Light emitting diode is actually, this is the basic structure of LED and the internal structure of LED. We are using LED chip, the flat side of LED, and each time electron recombines with a positive charge. Each time, but whenever there is a combination, there is a recombination of electron holes, the electron hole recombine with the positive charge particles, that's the holes, they produce electric potential energy. The electric potential energy is continuously produced and it is converted into the electromagnetic energy. Whenever there is a recombination of electrons and holes, they produce the potential, electric potential energy, and that potential energy is converted into what? It is converted into electromagnetic energy. For each recombination of negative and a positive charge, a quantum of electromagnetic energy is emitted. For each recombination of a negative and a positive charge, whenever there is a recombination of a negative charge and a positive charge, a quantum of electromagnetic energy is produced in the form of photons. So whenever there is a recombination of what? Recombination of electron and holes. Whenever there is a recombination of electron and holes, the quantum, a quantum is a huge amount, a photon, a kind of a bundle of energy. Quantum is a bundle of energy in the form of light. And a photon or electron of light is known as what? It is known as a photon. So that recombination of electron and hole, they produce a bundle of energy in the form of photon, and it is emitted at the output. And that photon is a term of light. So it is emitted in the form of photon of light with the frequency characteristic of a semiconductor material. So that is basically a kind of a light particle that is emitted whenever there is a recombination of electrons and holes. So that is what is actually happening in case of your LEDs operation. Now LEDs are basically used for the as a backlight for television screens. Normally, whenever we use LEDs, they are television screens. We are using for the backlight source. We are using as a backlight source over there. It is a full array, edgelit, and direct lit. This is the three main kinds of LEDs which are being used over here. So LEDs are full array. Full array means this method is considered the best LED backlight. Whenever we talk about the full array LED, this method is considered as the best LED backlight. The type of LED are distributed evenly behind the entire screen. This type of LED is distributed evenly behind the entire screen. This produces a more uniform backlight and provides a more effective use of local dimming. So whenever the pattern of LED, that is a pattern of LED, which is a form of full array. Full array means when our LEDs are used in a fashion, a complete fashion, in a rectangular fashion, or in a square fashion, or a triangular fashion. Arrangement of different LEDs in a square or in some particular pattern, that is known as an array. Arrangement of a various number of LEDs or a number of LEDs in a particular fashion, in a particular pattern, that is known as what? That is known as your array. So this is a kind of a full array which is being used in your LED screens or LED patterns for the this illumination purpose in case of your TV screens, local TV screens, and the illumination that is being provided by the LEDs is quite high. That is quite high, and it is not effective with the local dimming. It doesn't produce any dimming process. It produces a very high quality, this light that is being produced by this LED fashion of full array. Then the Edgelit. What are the Edgelit LEDs? The Edgelit LEDs is a method that is most common method for LEDs, and in case of TVs with Edgelit LED screens, the LEDs are placed at the peripheral of the screen. In this case, we are not, displaying, or we are not, distributing the pattern or the fashion of LEDs over the complete background of our TV screen, but we are just eliminating the edges or the peripherals. We are just eliminating the peripherals or the edges of the LEDs. So that is what is actually happening in case of your LED fashions. Then depending upon the television, it can be all around the screen or only on the sides of the bottom. So it actually depends upon the TV display also. Does the TV background requires the display over the complete background, or it requires only at the edges of the bottom or at the top? That depends upon that actually. How much kind of display it wants, which kind of display it wants, it depends upon that. This allows the screen to be very thin. This allows the screen to be very thin. It doesn't work for a thick screen LEDs. It works for a thin screen LEDs. Flash lighting or clouding is also one of the application of your edge lit LEDs. Then when we talk about direct lit, what is my direct lit? This is how the lower end LEDs are constructed. This is direct lit means this is how actually lower end means whenever we are talking about the lower strata of your LEDs. When we talk about the bottom screens of LEDs, they are how they are actually constructed and how they are working. That is being done by this use of your direct lit. Similar to full array method, the LEDs are directly behind the screen. So this kind of LEDs are not at the bottom edges or at the front edges. They are at the directly at the back end of the LED screen. These TVs are not very thin because of the space required behind the screen to add the LEDs. So these kind of TVs are not very thin. These kind of TVs are not very thin. They always provide a space because they provide a space that is required behind the screen to add the LEDs. So, and to diffuse the light over a big area. So the surfaces of such kind of LEDs, they need not to be very thin. Even they can be incorporated over the areas which are, which are at the huge structures or which are at the uh, thick ones. They need not be very thin for the operation purpose. Why they need not be very thin? Because they require a space behind the screen to add the LEDs. A space requirement is there which can eliminate the need of a thin LEDs. And they can diffuse the light over the big areas. Now, what are the various advantages of LEDs? What are the various advantages of LEDs that we are going to see over here? The various advantages of LEDs are they are effectively, efficiently high. The efficiency of LED is quite high. It can be used in various applications. I can see over here, we are using it over the displays, over the car lights and your traffic lights. On and off time is less, the slow failure lifetime is quite high, and they're very small in size. So they are easily applicable over almost all the areas. These are the major applications, advantages of LEDs. Disadvantages. What are the disadvantages of LEDs? They are a bit expensive. LEDs are a bit expensive. They are not that cheap. So this is one of the disadvantage of LEDs. They have the limited range of temperature. The temperature range is limited. It's not very high. It can't reach to a temperature to a degrees of maximum to 60 degrees Celsius it can reach. So they have a limited range of temperature. Restricted viewing angle. They have a restriction over the view point that we can view the LEDs over this restricted area only. We can't view it over above and below it. The speed is quite slow. The speed of LED is quite slow. That is another advantage or disadvantage of it. So that is all about your, LEDs. If you face any doubts, any queries, you can ask me at any moment of time. Thank you so much for patiently listening. Okay, class. So we can see it over here. This is the construction diagram of your LED, which we are using over here. This is the construction diagram of LED, which we are using. This is the outer casing of your LED structure. This is the outer casing of LED structure. This is the epitaxial or diffused N-type layer. N-type layer, because LED is nothing but it is simple PN diode. It is simple PN diode. And when we talk about the simple PN diode, what we are talking about is we are combining the two layers or two type of different materials. One is your P-type and one is your N-type. So it is a combination of P-type and N-type. And we all know that in case of your P-type materials, when we talk about the P-type materials, what we are talking about in case of P-type semiconductors, we are having the holes as majority carriers and electrons as the minority carriers. And similar in case of N-type semiconductors, what we are having is we are having the electrons. We are having electrons as a majority carriers and holes as your minority carriers. Now, what is actually happening over here is when we apply the supply voltage, we are providing this positive supply voltage, or we are applying this forward bias voltage. Forward bias voltage means we are connecting the supply terminal of the positive terminal of the supply voltage with the P type of your PN diode or LED diode, and N type of a LED diode is connected with the negative terminal of the battery. So this is your forward biased diode. This is your forward biased diode. Now, when we apply the sufficient amount of forward bias voltage over here, what actually happened is there is a recombination process starts. Recombination process, what do you mean by recombination process? Recombination process means their electrons, because electrons have a high mobility, they start moving from the N-type region towards the P-type region. They start diffusing from the N-type region towards the P-type region, and the electron hole pairs are made. They recombine to form the electron hole pairs and they liberate the energy. The energy is being liberated by the recombination process of electron holes in the term of quantum of or a bundle of energy that is known as light energy, and that bundle is known as a particle of light is known as your photons. So they are liberating energy in the term of photons. So those photons are emitted from the outer sheet because it is made up of glass. We can easily emit outwards in the form of emitted light or in terms of photons. In addition to this, we have the metal film anode connection and we have a gold film cathode connection. This is your anode connection, this is your cathode connection, and to anode and cathode we connected your supply voltages, that is your positive and negative terminal of your batteries. Anode is at the positive potential, cathode is at the negative potential. Similarly, we have connected the positive terminal of battery with the this P type or your this anode, and your negative terminal of battery towards the cathode. So this is the actually recombination process. Whenever we apply the forward bias voltage, the recombination process starts and emit energy in the form of light or a bundle of energy in the form of quantum of light, that the particles are known as your photons, and they emit the light. Similarly, in the form of light also, and it's a byproduct of heat energy. Some parts they emit light also, and they emit the light energy ke saath saath they emit the heat energy also. So that is why if we keep on if the LEDs keep on glowing for a long span of time, they get heated up. When you touch it, they get heated up. So there's a heat is a byproduct of light emission. Now this is a graphical representation of your this light emitting diode in the term of your forward current and forward voltage. This is the forward current and this is your forward voltage. With the increase of your voltage, there is increase in the amount of current. At near about at 1 volt, because operating voltage for silicon is near about 0.7 volts. So after 0.7 volts, it's near about 1 volt, we get the LEDs start working and they start increasing the amount of current. So with the increase of voltage, there's not a much increase in the amount of current, but at a single point of voltage, they attain a huge amount of current. Because of mobility of charge carriers, the recombination starts and that recombination produces the energy. Similarly, for the second graph, you can see it over here. We are having graphical representation between the radiated power and your forward current. So this is your forward current elimination and this is your radiated power. So as the amount of current is increasing, the amount of radiation is also increasing. If the now this forward current means what? Forward current here means the recombination that is occurring over here. The amount of recombination that is occurring over here, that is produced over here, is actually producing the amount of current. If there is a huge amount of electron hole pairs which are recombining with each other, that means they are producing a huge amount of forward current. And that forward current is actually reproducing some certain kind of radiations. And those radiations are emitted or they are radiated power. They are emitting the radiations and those radiations are emitted in the form of light. So this radiated power will increase with the increase of your forward current. As the forward current is increasing, the radiated power is also increasing. So this is what is actually happening in your LEDs and the graphical representation of the power that is being radiated out and how that increased amount of current is responsible for the generation of your light energy. This is what is actually we are learning in this LED structures, and this is what is actually happening in your LEDs, but which we are studying over here.